Hello, this is Tim Caskey of onsemi, and I'm the Senior Business Unit Director for the Linear Power and Amplifier Business Unit. Today I'm here to talk to you about high-performance LDO products, and specifically more understanding of PSRR performance. To start off, what is PSRR? Power Supply Rejection Ratio is a term widely used to describe the capability of an electronic device, and specifically here we'll be talking about an LDO regulator to suppress any power supply noise on the input to coupling to the output. In this case, on the input, it may be a noisy environment, a DC-DC switcher, or a long PCB trace that we want to prevent that noise from being coupled and have a clean, accurate signal on our output. If we look at a couple of applications and understanding why does PSRR matter in those applications, the first is an image sensor. The image sensor has dynamic loading anywhere between 1 kilohertz and 1 megahertz. And based upon the image that's being captured, there's variations in dynamic loading on the various different rails that happen every row read and between every row read. So in an example DC-to-DC application, there's a lot of noise that can be coupled onto the image sensor. Versus in an LDO, it has a very clean and consistent output. And I'll show you an example later that shows why high PSRR has an impact on image quality of that image sensor. The second application is a wireless RF. So in this case, we're showing a block diagram of a typical 802.11 Wi-Fi. And in this case, we have two LDO regulators that are filtering any power supply noise from the input from having any impact to the receive or transmit analog signals to ensure that we have consistent data throughput and that we don't lose any bits in the communication protocol. So let's look at understanding the PSRR curve in a little more detail. This is typically plotted in frequency in hertz versus ripple rejection in dB. And we've drawn a red dotted line here as we take a look at two regions of the PSRR chart. The first one off to the left-hand side, I like to think is more actively controlled by the LDO. So this has an input based upon the PSRR capability of the LDO and the bandwidth of the device. The second half, which is on the right-hand side, this is more an impact of passives that are in the system. Capacitors, load current, PCB layout. So those are also very important in the total system design, but not impacted by the selection of an LDO. If we look at an example of an ultra-high PSRR LDO like the NCP 163, we can see on the left-hand side it's a very flat PSRR curve. That's important for Wi-Fi applications in that low current range, 10 to 20 milliamps, when they're doing a receive or even in a transmit area. Then if we take a look a little bit farther out, PSRR is more important for image sensors in that higher frequency range. So for example, we want to see more than 60 dB at 100 kilohertz for an image sensor application. Let's look at a couple of factors impacting good PSRR performance. First one is selection of your LDO. Next is in the application design, use recommended input and output real capacitance values. Selecting the right capacitor. For some ceramic capacitors, it varies based upon the DC bias and the temperature range that your application is operating in. As we see in the example in the bottom left, adding more capacitance doesn't always result in improved performance. And then the third thing is optimizing the PCB layout. It's very important in minimizing any crosstalk from the power supply ranges that may couple into those rails. And the third thing is your operating conditions. Keeping the V in to V out voltage headroom large enough in the application. An LDO operating close to the dropout mode doesn't have the full range to be able to fight against the input ripple signal and can cause reduced PSRR performance in that application. So as we see in the bottom right, take a look at both min and nominal case to make sure that you're giving enough headroom for the LDO. So here's an example of several different LDOs that we offer, from 250 milliamps to 700 milliamps. The key piece is to look at the specifications not only at 1 kilohertz, which has been the historical norm for LDOs of only specifying that one frequency range, but really looking at what is the performance of that LDO across the different frequency ranges. So in your application, it might be more important to have higher PSRR at 1 kilohertz, or in another application, you might be more interested in 100 kilohertz. I hope you received some insight today on why power supply rejection ratio is an important parameter for applications like image sensors and wireless RF. It's important to understand the PSRR curve. Not all LDOs have the same performance across the frequency range, and understanding that is key in making your product selection of LDOs. The NCP16X, NCV816X family is the industry's best ultra-high performance PSRR LDO regulator. For information on these products and others, visit us at onsemi.com. Thank you.